Hi everyone, this is Dr. Kiranmayee, working as professor in the Department of CSC and also taking care of technical trainings at VNR VJEC. So today we have the lecture on circular queue. So why we need a circular queue when we already have a linear queue? So in the linear queue, already we have discussed in the previous video. So what is the disadvantage of linear queue is here from the front, whenever you want to delete the elements, here a free space is left over to the left hand side of your particular array, this one. So this unused space, whatever it has been shown in this particular array is kept unused. So for this reason, we have to go for a circular queue. So in a linear queue, after deletions, empty spaces at the front cannot be reused. So it leads to what? The wastage of memory and also causes the false overflow. Now, what is a circular queue? A circular queue is a queue where the last position of the particular array is connected to the first particular position of a particular queue, and then it forms a queue forms as a circle. So then efficiently whatever the spaces left over due to front can be reused efficiently. Now, these are the real world examples in day-to-day life we are going to see when compared to the circular queue. So, the traffic signal system, if you take it here, this forms a circular. That is, first you have a red light, then yellow, then green. After this, again, it goes back to the red. So, this forms nothing but the activities happens in a circular fashion. Coming to the music player, if at all there are 10 songs in a particular music player to be played, then it starts with the first song, then goes to the second, then third, dash to the till 10th song. And after playing the 10th song, again by default it comes back to the first song and start playing the first song again. And escalator, so this you're going to see in several malls and also in the airports where the steps will be rotating like this. So all these three examples resembles a circular queue. Now, in case of technically when we seek what is a circular queue means the array will be in a circular fashion. Now, this represents now the 0th index will be the front. And then here the 50 at the 4th index you have a rear. So now you can insert the elements at the rear end and delete the elements from the front end. So now when we are going to insert the elements using the rear end, that is after the nth minus 1 position, suppose 6, 7, 8 are inserted. After that the rear goes here. After the n maximum minus 1 position index, the rear goes to the index, 0th index. That is in a circular fashion. Now, so whenever you want to insert an element, that is insertion operation is called as an NQ operation. So already we have discussed this in a linear queue. But here in this particular case, we discuss about the circular queue. That is when a particular circular queue will be overflow. So whenever you want to insert an element into a circular queue, so we have to check whether it is an empty or else it is overflow. So now initially whenever the circular queue is empty, always your friend will be equal to -1 and rear is equal to -1. Then if you want to perform an NQ operation, so we have to set back both the indexing, that is the front and the rear, to 0. So now you start inserting from the rear end. So now you have inserted 7 and then you have to increment your rear. Now coming to this particular example, your front is here and your rear is over here, right? So here in the case of the linear queue, whenever you insert an element into a particular linear queue, we have performed an increment R is equal to R plus 1. Now, in this particular case, here we are going to follow a circular incrementation, that is R is equal to R plus 1 mod max size. So, this performs a normal increment, and also whenever the R reaches the max minus 1 position, it has to come back to the 0th position, that is the starting index of a circular Q. Then here your R is nothing but 4 and front is equal to 1. So now what is the next index of R? Is nothing but you follow R is equal to R plus 1 max size. So R is equal to nothing but here 4 plus 1. Okay, 4 plus 1 mod, the maximum size of the circular array is 5. So 5 mod 5 is 0. So the next index of the array after the last position comes back and it is nothing but 0. Now, coming over here, now your friend is here. Now, the rare comes over here and you have inserted 3. So, you have performed a circular incrementation and 3 got inserted over here. So, F is here, R is over here. Now, whenever F is greater than rare, see here, in this particular case, F is greater than rare. Now, your Q is overflow, right? So, or else you can say whenever your F is equal to R plus 1 mod max. Okay. Whenever F is equal to R plus 1 mod, then also we can say it is your circular Q is overflow. Means already it is filled. You cannot insert an element into a particular circular Q. Now, whenever you want to perform a DQ operation, right? So now see here, this particular array, your friend is 0, means pointing to 3. And your rare is 4, it is pointing to nothing but the element 1. Now, we can start performing DQ, that is deletion operation from the front end. So what you have to do now? You can delete the element. You can delete the element and then increment the friend. So now again friend, instead of saying F is equal to F plus 1, you can follow F is equal to F plus 1 mod max. So in this case here F is equal to 0. What is the next index of F? Means you can substitute 0 plus 1 mod max size. Here max size is nothing but 5. So 1 mod 5 is nothing but 1. So the next index of the friend will be 1. Now, whenever the friend is over here and rare is over here, again the friend after reaching the max minus 1, it has to come back to this particular position. Means again you need to follow F is equal to F plus 1 mod max. So what is the value of F is 4. So 4 plus 1 mod, you have 5. So 5 mod 5 is 0. So whenever F reaches the max minus 1 position, F becomes now 0. So both F and rare are 0 now. So still you want to perform a DQ operation. So delete this particular element and both the front and rare you set back to the minus 1. So I think it's clear that whenever your F is equal to minus 1, you say the circular Q is underflow. Otherwise, whenever the friend is at the max minus 1 position, you have to make it to come back the friend to the first index. And the next condition is when both front and rear are 0, after deleting it, both set back the front and rear indices to minus 1. Now, next we have the algorithm for checking the NQ performing the NQ operation into a circular queue. So just now we have discussed now when the particular circular queue will be full. So if you assume that this is a circular array, then this is the indexing. Now suppose your friend is here and the rare is here and the elements are like this. Means here the rare has been inserted from here and came back here, and the rear again inserted 2 elements over here, whereas the front already 2 elements got deleted and it is pointing to the 2. Now in this particular situation, your front is equal to, isn't it, when front is greater than rear. Okay, so that's the condition whenever f is equal to rear plus 1 mod max size, right? Then you can say your particular circular queue is overflow, means already it is full. And you have a situation where f is here, r is here. So this is also an overflow condition, 30, 40 and 50. So this particular is overflow. You can check this condition. It satisfies also. So either this or this particular condition will be checked. So if at all front is equal to rear plus 1 mod size, then you say your queue will be overflow. The elements already it is filled, you cannot insert. If at all, check whether your queue is empty. So whenever queue is empty means front equal to -1, then set to the front equal to 0, because we have to start performing the operations NQ and DQ. So otherwise means suppose you have rear is somewhere else over here, right? Suppose 10, 20. Otherwise, what you're going to do, you can perform a circular incrementation, increment rear, and then place the element over there. So this circular increment, it will be applicable for the normal increment and also for the increment whenever you have reaches the max -1, again come back to the first position. So then here this statement is to place an element at the rear end. Now coming to the DQ, that is whenever I want to perform the deletion operation in a circular queue, right? So here when this particular circular queue is empty means whenever it is f equal to -1. This particular case, your particular circular queue will be underflow. So you cannot delete the elements whenever the queue is empty. Otherwise, you can delete the element from the front end of the queue. And whenever a single element is present over there, suppose this element is there means here both and front and rear are pointing to the same index. So after deleting that element, you have to set both f and rear to -1. Otherwise means here you can perform the deletion operation. Suppose front is pointing to 10, 20, here the rear will be over here. So few elements are left over, you can perform a deletion operation. So delete this one and increment f. So increment also here you are following a circular increment. F is equal to f plus 1 is equivalent to f is equal to f plus 1 mod size. In this case, whenever it is moving from left to right within 0 to max -1. Whenever you want to bring back the max -1 to the 0th position, then the circular incrementation works perfectly for this and also for normal increment. Then you return whatever the element you have been deleted from the circular queue to the function. Now, coming to the display of a circular queue, I want to display the elements present in the circular queue. So now, suppose 10, 20, 30. So now, the front will be here and the rear will be here. So always from front to rear only you can display the element. This is one of the scenario. And the another scenario will be here. Suppose rear will be here, right? Front will be here. So 10, 20, 30 and 40. In this case, you have to print like this 10, 20, 30 and 40. So in this case also from front to rear, because it is a circular, you are going from max -1 back to the 0th index and again you have to print the element. That is the reason you are saying again I equal to I plus 1 mod size. So before displaying the content, check whether your queue is empty. So when the circular queue will be empty, whenever front is equal to -1, your circular queue will be empty. Otherwise, from front to rear, you have to print the element. So I equal to front. First, the element present at the front will be display it. Then if at all, check whether it is rare, because whenever it reaches rare, you have to stop. Here also, whenever it reaches rare, you have to stop printing the element. So if this is not true means you are going to increment to the next element. Print 20. Again display the element. Again increment. 30 will be printed. Again print. Next go to the next element and print 40. But in this particular case your I is equal to rare. Then stop this particular process whenever the element reaches the R. So this is about the circular queue. The main operations are, the first one is the NQ operation, second operation is GQ operation, that is the deletion, and last operation is to display the content of the element. So this ends with the circular queue lecture, and in the next lecture we are going to talk about the double-ended queue. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.